Welcome to This Explainer. Today, we're decoding the language of math and exploring the incredible universe of numbers. So, do you actually know the exact difference between integers, rational, and irrational numbers? Let's find out together. We'll start with natural numbers, 0, 1, 2, 3. They're literally the basic counting blocks of our world. Now, those expand into integers when we add negative whole numbers. Think of freezing, sub-zero temperatures. Next, let's look at the strict dividing line between rational and irrational numbers. It's super important. Rational numbers can always be written perfectly as a fraction or as terminating and recurring decimals. But irrational numbers, no way! You can't write them as fractions, and their decimals, like pi, never ever repeat. These mind-blowing categories weren't just discovered overnight, though. Let's take a quick look at their deep history. Hindu mathematicians laid the groundwork. Aryabhatta approximated pi, and Brahmagupta actually treated 0 as a true number.
Okay, so how do we build numbers up? Let's check out squares, cubes, and roots.
A square number, like 9, is simply a number multiplied by itself. We write it with a little index. Cubes take it a step further, multiplying the number 3 times. So 3 cubed equals 27. The square root works totally backwards. The square root of 16 is 4, but it's also negative 4. All right, now let's break numbers apart into their absolute core ingredients. We call these factors. Prime numbers are like math's unbreakable atoms. They can literally only be divided by 1 and themselves. You find prime factors by sequentially dividing a number, like 18, by primes to reveal its core components. So how do numbers interact? To find the highest common factor of 12 and 18, just compare lists. By listing out their factors, we can easily see the highest number they share in common is 6.
Conversely, the lowest common multiple is all about scaling numbers up until they eventually bump into each other.
For 2 and 3, the lowest common multiple is 6. It's the absolute smallest shared multiple they have. From natural counts to prime building blocks, this entire vocabulary of numbers forms a beautifully interconnected system. So I'll leave you with this. As our mathematical universe expands, what undiscovered numbers might still be waiting?